Hi, I'm Sami Kuba.
And I'm Kelly Akins, Program Manager for Incident Readiness.
And I'm on the Azure Communications team. Our team communicates to customers during impacting events. This could be a maintenance, a retirement of a feature or a service, or in worst cases, an impacting incident. Now, these incidents are inevitable, but impact to customers doesn't have to be. These sessions will walk customers through parts of our well-architected framework, whether it's taking advantage of the resiliency options that Azure makes available to customers, or the best practices for your application once they've migrated from on-prem into the cloud, or even troubleshooting your environment.
That's right. So we're here to translate those readiness recommendations into practical, actionable solutions to help you prepare for the unexpected, with our ultimate goal of helping you minimize or even prevent the impact of incidents. So we hope you enjoy the conversation. Thank you.
So if we go to our first slide, the first slide is a fantastic slide, and it's best read from the bottom up. At the bottom, we have the foundational services. These are things that Microsoft controls, and customers don't have too much control over them. It's how we operate and manage our cloud, how we operate and how we do deployments, how we patch, and so on. The middle tier is really the interesting tier, because this is the place where customers can identify the critical workloads, and we offer customers resiliency options, solutions, levers to pull, whatever you want to call it. But this is where customers can say, okay, these workloads are important. They can't go down, and they can pull some of the levers that are in there, and they can kind of add resiliency and some reliability to themselves. The top piece is pretty much on the customer side, on your side, which is where it's a terrible practice for customers to decide, I'm going to move to the cloud. And what they do is they take their application, they take it from an EMC or a sandbox, they put it into the cloud, and they say, okay, Microsoft's taking care of everything. So one of the things that we really want to land is that for you to move to the cloud and have a great experience and have your workloads be reliable, it's a shared responsibility. If we move over to the next slide, as I said earlier, we do acknowledge that incidents and outages happen. When we think about what's the customer experience when an outage happens, we think about our competitor. And our competitor in this sense is not AWS or Google or any other cloud provider. In this sense, our competitor is on-prem, because when you have an outage on an on-prem, you know what's going on, you get your updates, your CXOs know everything, we know what happened, and there are clear repair items. If there's an incident in the cloud, it can feel pretty much like a black box. And so we want to make sure that we're making the right investment. So there are 5 main work streams that we've put in so that customers can feel that it's not a black box and they know what's happening. The first investment is around speed, and this is to make sure that we tell customers quickly. Today, 75% of our outages are auto-communicated to impacted customers within 15 minutes of impacted through our auto-notification or our brain technology. The second piece is around granularity. Some of you are running hundreds or thousands of workloads in the cloud, and it's important that when there is an incident, we just don't say, virtual machines in a specific region, but we can tell you which virtual machines and which resources are impacted. The third one is around discoverability, where we'll do a click in later, and I'm sure many customers have done this, or many of you have done this, where you've gone to status.azure.com and you've had a look and everything seems green, and it's not always the case. We want to make sure that customers you have those right alerts set up so that we can send you a push notification when there's something going on. The fourth one is around parity, and parity means that not only our services have to behave and react in the same way, but our cloud must too. We sell you a Microsoft cloud, and sometimes you'll open the box and you'll see a Power Platform, a Microsoft 365, and an Azure. And we want to make sure that that convergence is happening. And the fifth one is really around transparency. When incidents do occur, we want to show up and share with you what happened, what went wrong, and what we're doing about it. And one of the things that we do now is an Azure Incident Retrospective, which means after a major event, we'll host a live call with customers similar to this one, and we'll have our engineering leaders here, and we'll talk to them about what happened, what are we learning, and we try and do all of this to rebuild trust. If we move over to the next slide, I'll be very quick. I wanted to have this slide up to myth bust some of the things that customers see. When we publish, the majority of our communications go to impacted customers. It's very, very rare that we use our status page. It's less than 1% of the time, and we only use this for major incidents. We've actually been very public around this is when we will use our status page, only in these few scenarios. I'm hoping someone can paste the link in the chat now. And then lastly, at times, of course, we do communicate on Twitter. We have our handle at Azure Support, but very seldomly will we kind of respond to there, because most incidents we're either communicating directly with customers, mostly directly with customers. Very seldom do we go to the status page or Twitter. But anyway, I'll hand it over to Kelly. Sorry, no, I won't. I'll hand it over to Jonathan Iwazaki. And Jonathan Iwazaki is going to speak to us about setting up a service health alert and really kind of getting those push notification when an incident occurs. Jonathan?
Well, thank you, Sammy. So as Sammy just talked about, when Azure is experiencing an incident or other events that could impact your workloads and your applications, we will notify you via Azure Service Health, which is what I have opened on my screen right now. And I am in the Service Issues blade, which communicates about incidents. And there are other types of events that I can check for as well, like planned maintenance, your health advisories, like if we're retiring a service or feature, security advisories, as well as some past communications and post-incident reviews in the health history. And now a very useful element of service health is the ability to have different alerts. And so we have right here the health alerts. So I'm going to select health alerts. And currently I can view in my service health alerts that I have two that showcase some of our best practices that you can use for your own service health alerting strategy. And so this one right here, this is for service issues impacting service types, network infrastructure, and the Microsoft Azure portal, which are both foundational layers in the stack and can be impactful to different users and customers. For example, all types of workloads and applications from IaaS to SaaS rely on our network infrastructure, and many users interact with the Azure portal interface to manage their resources. I also have a broad alert right here for security advisories, covering all the different types of services and regions within the subscription for the sake of this demo. So you can use those as some kind of foundational alerts in your service health alerting strategy. Now, let me walk through how to create a service health alert within the Azure portal. So I have the Azure subscription chosen that I'm creating the alert for. Next, we go to the conditions, which will cause the alert to trigger. And for the purpose of this demo, we are going to use virtual machines. And so I will go to virtual machines. And then I can select the region that we want to use. And for this demo, we will use East US and East US 2. And then for the sake of this demo, we will use service issue as the event type. And so this is incidents that we are communicating for. And then we go to the actions. And this is what we'd like the alert to do. And you can always use an existing action group. And for those, we can also use those existing action groups for other types of alerts, other types of Azure Monitor alerts. But for this demo, I'm going to create a new one. And so for this one, I will create the action group. And for the action group, we will use the name Readiness Demo Email. All right. Now, this is how I would like to be notified, and action groups support different types of ways for notifications. So for one way, if I'd like to be emailed, it also supports SMS, push to the Azure mobile app, or voice. And for this, I'm going to use email using the fictional company of Contoso. I'm going to select OK. All right, next, there are different types of actions that you can also have for your action group. And this also supports things like Azure Functions. You can push to a Event Hub resource. And then there are also webhooks that you can integrate with your IT service management system. And so well-known ITSM platforms such as ServiceNow, PagerDuty, and OpsGenie have integration features that allow for you to send alerts to them. And so if I did have some sort of integration URL and I wanted to use a webhook, let's say that I had one of those URLs from one of those platforms, such as like this, except with a real endpoint, it would send a payload that looks something like this. And it would have all this different information that my ITSM platform could parse through. So we have information in here like the impacted regions, impacted service. We have the actual communications right here, and you could configure your system to take additional steps based on this information. Now, for the sake of this demo, I'm not going to add this webhook since this endpoint is not real. But we will use the email that I had in the last step. All right, now that we have our action group, create that here. And I will now move on to the details for our alert rule. So just going to add some information in here about our alert rule. I'll give it a name. I can give it a description. And then if I wanted to add any sort of resource tags that will help me organize my resources, I can do that as well. Now, for the sake of that demo, I will skip this. And then now that I have all of this, I have, again, the condition. And so it's a service health alert. It's for virtual machines. It's in East US and East US 2 for the region. And then it's for the service issues event type. And it's sending an email. I will create. All right. Now, once this is finished deploying, it will show up here. And now that I've quickly kind of created that and walked everybody through, it'll give if I give it a minute, it would show up here with the rest of my alerts. And so I created a single service health alert, and there are also other ways that you can create these alerts in bulk and at scale. And if there's interest in seeing that or walking through that with us, then we can do that in another upcoming session. And there is the alert that I just created. So thanks, and I'll take it back to our hosts.
Fantastic. Thank you very much, Jonathan. Indeed. Thank you very much for the demo and a live demo, nonetheless. That's very brave of you. The service health alerts, while basic, are super important, not only to find out that there are issues going on, but also to get access to those Azure incident retrospectives that we spoke about earlier. If customers, or if you are impacted by one of these events, a service health alert is the best way. Kelly, now that we've covered the basics of a service health alert, what does the rest of the day look like? What does the rest of our content look like for folks watching?
Yeah, thanks, Sammy, so much. So as we're talking about, right, we're here to translate our readiness recommendations into actionable solutions so you can effectively prepare for the unexpected, with the ultimate goal, of course, of helping you minimize or even prevent the impact of incidents. So the first half of today's session is designed to enhance your critical application readiness using virtual machines in a lot of our demos, like Jonathan just did, as an example of that critical service that's powering that critical application. The second half will be focused on security and Power Platform, the amazing lineup of the team that we have, like Jonathan and Sammy, of course. We'll cover how to get informed, how to get notified and stay informed. We covered a piece of that, but soon I'll introduce you to Dan, who will talk a little bit more about how to stay informed and get notified. So whether that's with Microsoft needing to contact you or the application or security telemetry enabled to alert you about potential problems. The team will also talk to us about how to evaluate and increase the resiliency posture of that critical service, powering your critical application, and then testing this functionality. And then the team will also cover the top 5 ways to protect your environment. So thanks so much, Sammy. And as Sammy mentioned at the top of the hour, or when he started talking or having the slide deck, he talked about the shared reliability model. And we covered that your application, that top rung, is the responsibility of you to ensure it's configured and architect for the cloud. So Dan's going to be up next to show us how we could pull those amazing insights at the application layer to get the best possible signals to understand what's going on with your application, and recommendations on remediating issues and to increase performance, improve the performance. Dan, over to you.
Awesome. Thank you, Kelly. So I am going to be talking about one of our services, Application Insights, today. If we flip over to the next slide, there is a brief kind of overview of why I think application monitoring is important and where it fits into all the different topics that we talk about today. So first, what is application insights? It offers you performance monitoring and diagnostics for applications deployed anywhere. What I'm about to walk you through works easily on Azure, but can also be installed on your machines on premises. It offers you real-time telemetry data if you're trying to identify an issue, which is what our demo is going to take you through today. So where does this fit in? So I've summarized roughly, we've got application monitoring, we've got infrastructure monitoring, and then service health like we've just covered. Why I believe application monitoring is so important is because it's give you like the lowest latency to getting an issue in front of you, right? It's very quick to be able to determine if something goes off the rails, you'll be notified very quickly. Infrastructure monitoring does the same. However, if you're just thinking about like virtual machine level statistics, CPU, memory, that kind of thing, it doesn't immediately tell you where an issue may lie. And good application monitoring can actually help you a lot with that. All of these different options also have their own unique signals, and that's why it's important to think about all three. From an application monitoring perspective, some of the things we'll show you is the interaction between different bits of infrastructure, different applications and services, how they interact together. Infrastructure monitoring will tell you things before they hit infrastructure that you own, such as networking, for instance. And then from a service level, Jonathan just showed, you can see things like upcoming maintenances or events that are impacting the region as a whole. So if we move over to the next slide, brief introduction to the demo that I've just pre-recorded, so I'm not as brave as Jonathan. This is a very simple application that I have inherited. It is a website for a pet clinic. It has two main components, an app service and a MySQL database in the backend. It uses Key Vault to store the credentials for the database, and that's pretty much it. All I've done just prior to this demo is enable application insights. The way to do this yourself, if you'd like, we have this environment easy for you to spin up if you want to have a play with the technology yourself. The code at the bottom will be posted into the chat as well. You run those commands and you'll have the same environment that I do. So we'll go ahead and flip over to the next slide and play the video. This is the website. Its homepage is extremely simple, as you can see. And we are just going to look at one of the bits of functionality of the website, which is looking for pet owners. So this website will register appointments. It will show the pets that they own. And from first glance, the website appears to be up, but the moment that you try and use the search field, you'll see that an error has occurred. Like simple high-level monitoring won't show you, but what we can do with application insights is look at errors that have occurred on this application. So on this overview blade for application insights, what you can see here is the requests for this website are fairly consistent, but around 250, you see that an increase in failures has started occurring. Figuring out what may be going on is incredibly easy with application insights. So using the auto instrumentation feature, without having to make any changes to the code, you can actually see the main exceptions that have occurred without having to introduce any kind of additional setup or rules. These are all automatically instrumented. So what I can do is look at one of the exceptions and see exactly why this page may be failing. If a user opens up the page, after 30 seconds, they appear to be having a timeout. I can see from the back end that the application appears to be timing out. If I open up the call stack, I can see exactly what error has occurred. In this case, Java's default connection timed out message has occurred. If we load this up, we can see the exact connection failure that has occurred. In this particular case, it's unable to establish a database connection. Now, there's many reasons that something like this can go wrong. The main reason for us, it could be an incident on the platform, or the most common cause of failures is change. If we open up change analysis in Azure Monitor, we can see all the different changes that have occurred on this subscription. And by opening up this particular blade, I can see exactly what changes occurred. You'll note that around the same time the incident started occurring, this particular setting was changed. This is a good indicator of what may be causing my issue. By opening up the affected resource blade, I can see that this particular toggle, allowing network access to my database, was erroneously disabled. So I can open that up, hit save, and in a minute, you'll see that this website will start working again. One of the main reasons for outages is change. And this is why this is so important to be able to have this functionality available to you quickly. So if we open up Application Insights while we wait for the application to recover, I just want to show you two more blades. The first one is availability. The availability blade allows you to set up monitoring for specific pages and monitor them from different places around the world. If you open up the edit page, what it'll show you is the URL where you can monitor, but there's some additional functionality that's really handy here. The first one is checking for if the SSL certificate is still valid and if it's going to expire anytime soon. The other blade that I want to walk you through is the performance blade. So what this allows you to do is look through what pages are taking the longest to load and if this is inconsistent across users. So you're able to look at, let's say, the 99th percentile of specific requests that may be failing. If they are taking way longer than others, so let's say way beyond 100 milliseconds, that may indicate a performance issue. Now, everything I've shown you here today, you can set up alerting for. So whether it's availability, an increase in exceptions, response time, all of these various different signals you can look at and set up an alert for. All of this kind of functionality, and that's kind of the important thing to note here, is out of the box. So there's nothing you really need to do to set this up. If you see now on this main page, you'll see that the website has recovered and I can access my website again. That's just a very, very simple demo of how you can use Application Insights to quickly diagnose an issue. So with that, I will hand it over to Sammy.
Very much, Dan. I really appreciate it. And even though you lack a bit of cloud cred with the recorded demo, I have to say it was pretty seamless and slick. Thank you very much for that. I really like it because it shows that service health alerts that Jonathan set up earlier are not the only alerting that customers need to be to have configured in order to know there's an issue. So thank you very much for showing us some of the coolness of App Insight. Kelly, who do we have coming up next?
Yeah, thanks so much. So we have Satish coming up next, and back to that shared reliability model. We just went through that application, your application. Now we're moving down into the resiliency features. And so Satish will tell us, hey, what resiliency features are available for that critical service that Microsoft built, and what options are available to implement that would best fit our organization's needs. And then before we build a fault injection experiment to test the behavior of those resiliency recommendations that we implemented, Chris will give us an overview of chaos engineering. He couldn't be here today, but he did pre-record a video that we'll be sharing shortly. And then after that's over, it will be back to Satish to walk us through an actual chaos experiment. So Satish, over to you.
Thank you, Kelly. Obviously, Reliability Workbook is part of Advisor Workbook feature, which is focusing on helping you improve the workload reliability on Azure. Reliability recommendation as part of the workbook, which can be implemented to increase the resiliency posture on the workload. So there are guidances which are available as part of well-architected framework. If you see my demo page, I'm in the well-architected framework, service-specific best practices, where we see the virtual machine best practices for resiliency. So when we move into a demo, so we are in Advisor portal. Let's navigate to workbooks. And under that workbooks, there is a reliability workbook. Obviously, we can come to the recommendation section for reliability, and there is a hyperlink which can land into this workbook as well. But once we land into this workbook, right, we will see an overview on what this workbook is all about, and some links to submit the feedbacks and some of the services which is being supported, along with the usage instruction for this workbook. As mentioned in this usage instruction, right? So this workbook can be filterable by subscription, resource group, environment, and tags. So there are a couple of features like show SLA and show help, which helps to provide information around what are the service-specific best practices you need to keep in mind to achieve the highest SLA, and some of the well-architected recommendations which you need to consider while implementing. So let's navigate to virtual machine section under compute. So now we are in compute and virtual machines. Here we have SLA section, which talks about what is the configuration which we need to keep in mind to achieve the highest SLA. Here, if we see, we will get highest SLA when we have availability zones deployed. Similarly, there is show help, which talks about the well-architected recommendations here. Once we go into those details, let's open the details section. Here, we will see different virtual machines, which are part of my subscription and resource group. So we see the state of the virtual machine, whether it's running or not. And obviously, the best practices like availability zone and availability set, which is applicable under this subscription, right? So if we scroll it a bit, right, so we will see the disk specific recommendation as well, whether we are using managed disk with the premium, which is highlighted in green, and if there are any unmanaged disk or disk which is not as per best practices, then we are showing it as an alert icon. Obviously, we are also looking at backup configuration as well, whether the backup is healthy or not. And in this case, we are also showcasing whether the backup has been configured at all. So if it is not configured, we are showing it in alert icon. So this is how we can use this reliability workbook to monitor a service specific recommendations. And obviously, there is a summary view on the top, which talks about what are the open items which are there in the details section, so that we can use it for tracking purposes. So finally, there are other sections like storage, networking, etc., where we can use the same format. And there is a service alert section, as Jonathan pointed out, right? So we can configure service alerts for our subscription, and we can monitor the service alert configuration here. For example, in this particular subscription, we do have service issues configured and some security advice is configured as well, but there hasn't been any configuration for plant maintenance and health advisories. So this is how we can monitor the service alert configuration. So once we have used the reliability workbook to improve the resiliency posture of our workload, now we can go ahead and take a step back and proactively inject the faults into the workload and test for the service resiliency when faults occur. So this is achieved by Chaos Studio service on Azure. Let's hear from Chris on how Chaos Studio helps in injecting faults and testing the resiliency of the mission critical workloads.
Hi, everybody. My name is Chris Ashton, and today I'm going to talk to you about Chaos Engineering and Chaos Studio and how you can use these things to build applications. The cloud has revolutionized application development. Management and maintenance of physical infrastructure is eliminated, and a marketplace of PaaS services enables faster development of more complex applications. However, service outages and disruptions bring new challenges that must be dealt with differently than before. A lightning strike can disrupt power to a data center halfway around the world, or a flood can take out a rack of servers. A new operating system version or firmware update can introduce unforeseen incompatibilities. To be prepared for operation in this kind of an environment, applications must be designed to be resilient, and you must validate this resilience in a safe environment before you deploy to production. This is where chaos engineering comes in. Chaos engineering is the practice of subjecting your application to the real-world disruptions it will encounter in production through the practice of fault injection. Design your application for failure and architect it for resilience, then test this so you can deploy with confidence. In chaos engineering, it's common to leverage the scientific method to perform hypotheses about your application's response to disruptive conditions. Then you can conduct experiments in a safe environment and analyze the results, make improvements, and repeat the process. If you have designed around availability zones, region pairing, or taking backups, your hypotheses might then involve what happens when an availability zone goes down, or there's region isolation due to a network outage. Chaos engineering is more than just simple testing, though. It enables you to validate your architecture and code choices, and it also enables you to validate your deployment configuration settings, your observability and monitoring components, and then your people processes. And now this is where Chaos Studio comes in. Azure Chaos Studio is a new Azure service that helps you measure, understand, improve, and then maintain product resilience using chaos engineering and fault injection techniques. Chaos Studio is a fully managed service with deep Azure integration. You can leverage its Azure Portal user interface and Azure Resource Manager compliant APIs to perform manual and programmatic chaos experiments that leverage a growing library of fault actions to orchestrate real-world disruption scenarios. Chaos Studio can orchestrate fault injection actions in sequence or in parallel, which allows you to combine fault actions like CPU or memory pressure on your VM instances with something like a Redis cache reboot or Cosmos DB failover to validate what happens when things go differently than expected. Chaos Studio also has safeguards in place to ensure that this is done against only the resources you want and by authorized users. A chaos experiment is the heart of Chaos Studio. Before you can run your first chaos experiment, you will need to set up a few things. Deploy your application to a test environment, onboard your application's Azure resource dependencies to Chaos Studio for use as targets, execute a workload against your application, and ensure that there's observability in place so that you can monitor your application's health before, during, and after chaos. Chaos Studio then provides the fault injection actions that disrupt your application. Here's a quick look at our fault library. On the left, you'll see our agent-based faults. We have a chaos agent that can be deployed to your Windows or Linux virtual machines, and then it can do things like add CPU, memory, or disk pressure. It can kill a process or block access to things on the network. In the middle, you can see our service direct faults. Here, no agent is required, and Chaos Studio can talk directly to other Azure services to induce fault injection behaviors like shutting down a VM instance, rebooting your Redis cache, or disrupting access to your Key Vault secrets. You can then use these faults to build up scenarios like an availability zone outage, or you can see what happens when DNS or AAD goes down. You can also perform a game day or a drill to see what happens when you have a Black Friday sales event or when something like Taylor Swift tickets go on sale. This has been a really quick introduction to chaos engineering and to Azure Chaos Studio. See the link here for more information, and good luck as you begin your journey along chaos testing.
Now you have heard from Chris on the Chaos Studio. Let's see this in action. For this demo, we are going to show you how you can inject a VM shutdown fault to a VM, which can be used to simulate a zonal failure scenario for your mission critical workload running on multiple VMs across zones. In this scenario, you should ensure that the application continues to function even if few of the VMs goes down. We have pre-created a virtual machine with user-assigned managed identity. So this is the VM which I have pre-created, and we have assigned a user-assigned managed identity, and we have assigned the right access control for this VM with the VM contributor role. So let's navigate to the Chaos Studio and onboard this VM for the targets. So now I have chosen the right subscription and the resource group, and I see a bunch of VMs. Here I pick my virtual machine, which I have pre-created, and let's click on Enable Targets. And this will lead to a review page. Once I review the VM, I click on Enable, and it will just enable this VM for these targets. While it may take a few seconds, you see other VMs have enabled the service direct faults. And if there are other type of faults where like CPU or memory, which I need to inject, I need to onboard it for the agent-based faults. So now we have, while it's trying to onboard, let's go ahead and create an Chaos Studio experiment and see how it works. Let's go to the experiments page. Let's create a new experiment. Here in this page, let's pick the right resource group and name of the experiment. and pick the right region. And next, we need to provide the right permission. So in this case, the user assigned managed identity have the right permission. So let's use that identity here. Here, this identity is under my subscription, and this is the identity which I have pre-created. Let's go ahead and add and navigate to the experiment designer section. So this is where we will configure what are we going to do with this particular experiment, right? And there are steps and branches here, and steps run one after another and branches run in parallel. So for this particular experiment, we just need a single step and a single branch under that particular step. Let's name this step as VM shutdown and name the branch as process kill. Now we need to add an action, which is add fault. And we need to pick the VM shutdown fault here. Being loaded. So yeah, so under the fault, if we scroll at the bottom, we see VM shutdown. Let's pick it. And here we can customize how much duration we need to run this fault. So let it run for 10 minutes and navigate to the target resources. And this is where we need to select our resources which we have already onboarded as part of targets. And this is the VM which we have initially onboarded. Let's add this and navigate to review page. It will validate whether the experiment has the right permission to run and everything is green. Let's go ahead and click on create, right? So this will create a new experiment. In this case, yeah, it will take a few seconds, but I do have a pre-created experiment here. Let's go ahead and see this. This is a brand new experiment, which I follow the same steps. Let's go ahead and start the experiment. Right. Once we start the experiment, the experience will look like this. So currently the experiment is being run. If we click on details, we will see what are the steps it has been executing. So there is a branch which is running, and then there is an action which is being run. So now the VM has been successfully shut down, and this is exactly the simulation which is mainly for the VM zonal failure. We can obviously monitor this in Advisor Workbook as well. So I'm going back to the workbook, and if you see this page for this particular VM, right? So Chaos Demo VM3. So the VM is in start state. So this is how we can observe the VM status as well and inject different faults for your mission critical workloads. So currently this service is in public preview. It might go GA very soon, and we are pretty excited to see how you can utilize this to inject end-to-end faults for your workload. That's all for the Chaos demo. Over to you, Sammy.
Super, Satish, thank you very much. And again, big props for doing a live demo as well. Every time I'm a little bit nervous, but it's going great. I'm such a big fan of Chaos Studio, and I've been following from the preview stages. You've been building out your libraries. I think it's really cool. So I'd encourage customers, like Chaos Studio is a fantastic tool for injecting faults and seeing how applications respond. Kelly, how are we doing? Who do we have next?
Yeah, so hey, thanks, Sammy. Yeah, I totally agree. That was an awesome demo with the service health alerts, application insights, reliability workbook, and chaos. So now we'll be shifting our reliability conversation to the security side of the house. We're still in that shared reliability model with the resiliency features rung. So Seisha and Sarah will talk to us about the top 5 ways to protect your environment and the importance of security advisory communications, especially as we're seeing globally an increase of cybersecurity threats. So Seisha, Sarah, over to you.
Thanks, Kelly. I'm so glad Jonathan walked us through how to set up service health alerts, as such an important factor to prepare for the unexpected. Hey everyone, my name is Seisha Manchiraju, and I'm from the Azure Security Communications team, and I'm joined by Sarah Adair.
It is such an honor to be at this first ever event to share about how you can protect your Azure investments. As Kelly introduced, we're going to cover Azure Security Comms process, our top recommendations for securing your environment, and a demo of our security advisory experience in Azure Service House so you can see what to expect. So Seisha, please kick us off.
Thanks, Sarah. Before we dive deeper into how to protect your investments, I'm thrilled to tell you about Azure's security communications process. When Microsoft becomes aware of a security incident, there is an entire process that must be taken into consideration before the impacted customer receives an Azure Service Health alert. When an incident is identified, whether by an external researcher or internal detection, the relevant service team and the Microsoft Security Response Center, or MSRC, work hand in hand to understand the impact of the vulnerability or bug, the security implications, and what mitigation looks like. When the response team realizes there is customer impact or there is a need to communicate to customers, our team, Azure Security Communications, is called in. We seek to understand the nature of the vulnerability, the timeline of events, and the customer impact, including any required actions the customer needs to take to protect themselves. We use this information to develop the overall communication strategy, both externally and internally, to help ensure the best experiences for the customer, Microsoft's field, support, and leadership teams.
And this is why it's so important that you have your Azure Service Health set up to alert you when there is a security event, so that when we do send one of these security advisories, you know where to receive them. Now let's go to the next slide, where we'll cover the top 5 ways to protect your investments.
Monitoring your environment for suspicious activity is such an important and easy first layer of defense. You want to quickly know if any bad actors have broken through your security layers and shut them down immediately. There are a number of ways you can secure your environment. Get us started, Sarah.
Okay, so first things first, every customer should enable multi-factor authentication, or MFA, on all of your admin accounts, if not all of your users. MFA is the simplest way to add an extra layer of security to your investment.
In the same vein, you should configure conditional access to ensure you are notified when there is a risky user in your environment. Risky users are identified by anonymous IP address use, atypical travel, and unfamiliar sign-in properties. The identification of these users will further trigger remediation efforts such as multi-factor authentication, resetting passwords, etc., ensuring that you remain secure.
Yes, and on this note, it's equally important to have reachable email addresses for key Azure roles, like your subscription admin, global admin, technical contact, and security admin. In addition to the service health alerts, this is what Microsoft will use to contact you for our most urgent security incidents.
Next tip, make sure to rotate your credentials for all your global and subscription admins regularly to protect against potential security breaches and compromise scenarios.
And our final recommendation is to use policies to control the movement of your subscriptions from and into AAD directories. This is a preventive measure to be aware of who's in your environment, and should a threat actor try to hide your subscriptions by moving it into another directory.
Thanks for that high-level overview, Sarah. Now I'd like to switch gears to a demo. Setting the stage. When a communication is related to a security event, we send it as a security advisory that will show up in Azure Service Health. Let's head on over to the Azure portal to see for ourselves. Following Jonathan's demo, here is Azure Service Health, where you can receive communications for all event types. We saw service issues. Now I'm going to dive deeper into security advisories. As you can see, we have 3 examples of security advisories you can receive for a myriad of issues. Looking at the body of the communication, you can see some metadata here. We have the tracking ID, we have impacted services, we've got regions, subscriptions, when the communication was last updated, and the body of the communication here. We also have this option here to download the communication as a PDF, which is particularly useful if you have folks who may not have direct access to Azure Service Health, but would still like a copy of the communication. It is also important to note that this is available for all event types, not just security advisories. All right, so now let's dive deeper into the specific communication. So this is an example of a common vulnerabilities and exposures, or CVE, communication. MITRE tracks and identifies CVEs in publicly released software packages, and when Microsoft realizes that Azure customers are impacted due to a CVE, we send security advisories to customers, letting them know of this CVE and any mitigation steps you need to take. So this communication was sent as a response to the recent vulnerability documented in CVE 2023-36868, which affected Service Fabric virtual networks. Our security communications typically require any required actions, if any. In this case, the customer is advised to upgrade their vulnerable Azure Service Fabric clusters to runtime version 9.1. This is an example of a first-party CVE communication, as this vulnerability affected customers running an Azure service. All right, so now let's take a look at another example of a CVE communication. This is an example of a third-party CVE regarding the recently disclosed vulnerability known as Zenbleed, which you may have heard of. This was in regard to CVE 2023-20593 for an AMD vulnerability. This vulnerability affected virtual machines running AMD EPYC processors, and the call to action here is to update virtual machine instances to the protected version. All right, our last example of a COM is for customer compromise scenarios, which we send communications for when we detect suspicious activity on the platform that is or could impact the quality and reliability of Azure services. This communication details the required action that the customer must take, namely to follow these steps listed here to secure their resources. So be proactive and take such actions before you get one of these communications. And with that, that brings us to the end of our demo of security advisories in Azure Service Health. We hope you learned a bit about how to secure your resources, protect your investments, and in general, how security advisories look in Azure Service Health.
And thank you, Stacia. That was a great walkthrough of the security advisories. Now that we've covered the Azure side of the house, handing it back to our hosts.
Super, thank you very much. Thank you, Stacia. Thank you, Sarah. I'm already feeling a little more safe and secure. My takeaway actions are, if I was to do one thing today, it's MFA, and unauthorized users could be abusers. Kelly, who do we have next coming up on the show?
Yeah, thanks so much. So yeah, MFA all the way. I had to say it, had to get that in. So what's up next? The previous sections, we focused on the shared reliability model for Azure. Now we're going to switch gears, and Tim from Power Platform is up next to talk about how this model shifts when you move outside of Azure, but still under that Microsoft cloud. Tim, take it away.
Thank you so much, Kelly. As you look across the spread of options available in the Microsoft Cloud, there are some differences in how you keep up to date with service health across the products. In the low and no code platforms and the apps built on them, we have to take a slightly different take because those products, while they magnify productivity, they come with a challenge. Knowing what's going on in the infrastructure layers becomes very difficult. In the Power Platform and Dynamics 365 apps space, we built the service with many of the same tools and design patterns that we just talked about. And we've approached the challenge of providing robust service health alerts and visibility through the Microsoft 365 and Power Platform admin centers. On the next slide, we can take a look at what that looks like. Surfacing service health messages in the Microsoft 365 Admin Center allows us to use a common place to publish information about incidents, advisories about service degradation, to service administrators leveraging a common role-based access control model that's already used to manage your services. In addition, we want to provide visibility in the places you may be managing your environments and resources, so we surface the alerts in the Power Platform Admin Center as well to those authorized accounts. On the next slide, we want to talk a little bit about how we know the solution doesn't work for everyone. And we know that organizations need different tools to operate at scale. To help address these needs, our service messaging is available through Microsoft Graph, allowing you to integrate communication data into existing workflows, include status and details in support-focused dashboards, and use third-party connectors to get your service health where you want it. What this means, on the next slide, we have a few calls to action. This has been a whirlwind tour of the tools available to you. So we can summarize by asking you to please familiarize yourself and your organization with the service health experiences available in the Microsoft 365 and Power Platform Admin Centers. Explore the options available for email notifications for events and incidents, and evaluate using Microsoft Graph to incorporate this content into your existing workflows and event responses. So with many thanks to you all, I'll hand this back over to Sammy and Kelly.
Thanks, Tim, so much, and team, and to all the presenters. So what We've covered a lot, like Tim just mentioned, and we really hope that linking our recommendations in these bite-sized sections with our tools demonstrated how these recommendations can come to life and be implemented effectively, with the bottom line of helping you get better prepared for the unexpected. So just doing a quick recap of our call to action all up from this hour with you. So configure service health alerts. So you'll be pushed Microsoft service health information to you, not you needing to go search for it. Set up application insights to get the telemetry at your application's lowest layers. Build applications that can tolerate faults based on your organization's needs, using reliability workbooks to quickly assess your resiliency posture, implement those recommendations, and then run Chaos Studio fault injection experiments to monitor how your applications will hold up. Review and implement the best practices that Sasha and Sarah discussed to protect your environment, like MFA, rotating your credentials, risky user alerts, current contact information, stay updated, and control the movement of your subscriptions. And last but definitely not least, let's familiarize ourselves with how to stay informed in the Power Platform world. Sammy, do you have anything else that you'd like to share?
Yeah, super. Thank you very much, Kelly. I have enjoyed the conversation. Generally what we've done, we have this WAF, or a well-architected framework. It's publicly, it's online, it's on all our docs for building reliability and security best practices. And what we've done today is we've taken a little bit out of that WAF. It's quite extensive, and I think customers need to be mindful that this doesn't need to apply to every single workload that they have going on. That it would drive anybody mad. But the idea is that customers select and say, this is important to me, I'm gonna add some layers here, and this one is, the dev test stuff, we can kind of potentially leave it alone. If customers do have a unified or premier account, please speak to your CSAM, understand how you can get a MERP in place, or a Microsoft Incident Readiness proactive resiliency review. It's an acronym. I'm not too sure what they all mean. One of the key things as well that Jonathan mentioned about the service health alerts, that one of the reasons I really want to drill this is we mentioned our Azure incident retrospectives earlier, following major incidents. We have one coming up very shortly as well. Please set up those alerts so that you can get invited to those. Generally speaking, when I look back at what we've done today, it is very one-on-one nature. Setting up a single service health alert, absolutely. Jonathan mentioned, hey, we can do this at scale. There are ARM templates, PowerShell, using Azure policy. So as you onboard subscriptions, things just happen. And we really want to understand that there are many things that we can talk about in these sessions. We can talk about how Microsoft builds services on top of Azure. We can talk about Azure Monitor, baseline policies, and so on. Really, 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 we want to tailor these events for you. And so we cherish your feedback. Every piece of feedback that you give us will be read by every single member of the team. And as we kind of get into a cadence of doing these, we would love to build a program that's really going to benefit all of you. So thank you very much for joining us for this last hour. It's been wonderful. Thank you very much.
Thank you, everyone.